Hi, in this video lecture I would be talking about array. So I assume that you have some basic understanding of programming language and some basic understanding of asymptotic time and space complexity. So the topic of discussion would be what is array, array declaration and storage, initialization of array, and some basic operations that can be performed on array such as traversal, insertion and deletions. So let us start with our discussion. So the first topic of discussion is what is array. So array is a linear data structure which is a collection of homogeneous elements. So the first point that is to be noted here is what is linear data structure. So linear data structure states that the elements are stored in some sequential fashion. So not only the storage but also the access of the elements are in some sequential fashion. So the second important point here is the homogeneous elements. This means that the elements that are stored in the array should be similar. For example, if the array is of integer, it should store only integers, and array of characters should only store characters, and etc. So one note here is that for non-similar elements, that is for heterogeneous elements, we go for other data structures like structure. So the pictorial representation of array is done by consecutive blocks like here. So this is an array of 4 integers represented in the form of 4 consecutive blocks. Now we would move on to the next topic, array declaration and storage. So the declaration statement is an instruction to compiler for providing memory to the array, that is for the memory allocation of the array. So this is one example of array declaration. So in declaration statement we provide the data type which we want for the array name, here it is A, and the size of the array that we want. So for this example, this is the declaration statement of an array of 5 integers. The second example is char b6. So this is the declaration of an array of 6 characters, because the data type which is specified here is char, and the name of the array is given here is b, and the size of array given is 6. So these are the two examples of the declaration of array. The next point is storage of array. So the storage of array is always done in the contiguous memory blocks. So what do we mean by contiguous memory blocks? So let's take this example first, in which we have declared an array of 5 integers. So let's suppose that the integer is taking 2 bytes. So the storage of this array would be like this. So let's suppose the first element is stored at the address 100. So the first, as we have supposed that the integer is taking 2 bytes, so this first element would be taking 2 bytes. So the next element should be stored contiguously, means the next element should be stored at 100 plus 2 byte, that is 102 bytes. Again, this element would be taking 2 byte. So the next element should be stored at 102 plus 2, that is 104 byte. So this is called the contiguous memory allocation. So in this way the array is always stored. The address of the first element of the array is known as the base address of the array. So one important point to note over here is that the name of the array is defined as a constant pointer when we declare any array. So for example, here we have declared an array with array name A. So this would be defined as this A, which is the array name, would be defined as a constant pointer. And one more important thing is that it contains the base address of the array. So here we have discussed the base address. What is the base address of the array? So base address is the address of the first element of the array. So here the base address is 100. So for example 100 would be stored in A, which is a constant pointer. So this, what does it mean is that whenever we declare an array, this A pointer would be created because A is the array name and it would be storing the base address, that is say 100 of the array. So this is all about array declaration and storage. Now we would move to the next topic, which is initialization of array. So initialization is the assignment of the initial value for a variable. So for example, again consider the example 1 in which we had declared one array. So we had declared one array of 5 integers. So in initialization we basically assign the initial values for the array which it would store. So this is the syntax for the initialization. So there would be semicolon over here also in C or C++. So A equals all the elements. So the size of the array is 5. So 5 elements have been initialized to it. So this is how the initialized array looks. You can see that the first element is stored here, again the next element, and so on. These are called the indices of the array. So basically indices are the positions at which the array elements are stored. In C or C++, the first index is 0 by convention. So C++, basically when we declare or initialize the array, the first element is stored at 0 index. So with the help of these indices we can access the array directly. For example over here, so let's suppose we want to print the element at the second index. So we can say cout A2. This cout is an operation, is a statement for printing anything in C++. So cout A2 would print element at index 2 of this array if it is in C++. Again, the second example of the access of an element means the second thing for which we can access any array element can be for replacing the element. So let's suppose we want to replace this element 5 which is at index 3. So we can say that we can just give a instruction like A3 equals 6. So this element on the third index of array A would be replaced by 6. So this is the example of how we can access the array, and before that we have seen how to initialize the array and how the initialized array looks. In the indices, this 0 is known as the lower bound and the element is stored up to this fourth index, so we can call it upper bound. So lower bound equal to 0, upper bound equal to 4. So these two indexes or the bounds, we can say, can be used for various other algorithms which we would implement on array afterwards. So here are some more points on declaration and initialization. So we have already seen this type of declaration in which we have declared only, did only declaration, means no initialization has been done till now. So this, in this case, when we only declare the array, all the elements of the array would be garbage values. Means garbage values means anything can be stored which is irrelevant. So it can be anything like minus 60, 60, 70, anything can be stored over here when we only declare it and we don't initialize any value. So the next point is when we can also declare and initialize at the same time. So consider this case in which we have declared this like int a5. We have told the compiler to create one array of size 5 integers. Okay, so and then we have told the compiler in the same statement to initialize the values with 2, 4, 6, 8 and 10. So this can be treated as creating an array of size 5 and also initializing the values into the array. So the array would look like this. All the elements have been initialized. So these are the two types, and we'll see other types also. So this is the third thing. So let's suppose we declared and initialized, and in this case we declared the array of size 5 and we only initialized with 2 values. So what would be done for the rest of the spaces? So in this case the remaining elements would be initialized by 0. So this is done automatically by the compiler, because once it has started initializing the values, so it would not fill garbage values to the rest of the places. Instead it would store zeros at the remaining places. So this is the case, this is the third case. So using this case we can just initialize array of zeros also. There are several, in several languages we have different functions for initializing array of zeros. For example, in Python we have one function zeros, and in which we can specify the size of array. Let's suppose 5 I specify, and if I execute this statement, it would just create array of zeros of length 5. So these kind of things, this kind of execution can be done by using the previous concept. So for example, let's suppose I create one array of size 5 and initialize the first value to be 0. So the first value would be 0 as initialized by us. So I told you that if we don't initialize any, if we don't initialize the rest of the values, the compiler automatically initializes them with 0. So these all 4 values would be initialized by 0 by compiler itself. So this can be used for initializing array of zeros. The next example, the next case is when we don't specify any size of the array and we tell the compiler to initialize the array with these values. So even if we have not specified any size of the array would be created of the same size of the number of elements which we have initialized. So as the number of elements which we have initialized is 5 length array would be created, and all the spaces would be filled by these elements consecutively. So this is all about initialization and declaration. So now we would start with the basic operations which can be done on array. So the first operation which can be done on array, or which is done on array very frequently, is traversal. So what is traversal? It is basically visiting each element exactly once. So for example, consider this array, and these are the indices of the array. Suppose that the elements stored in this array are 5, 4, 1 and 6. So what traversal would do is what we discussed before, that it would visit each element exactly once. That for this array it would visit every element, means that it would visit this element, then this element, then this and this. So while visiting the elements, it can do other things also. So this can be considered as the applications of traversal. So the various applications of traversal include counting the number of elements, calculating the sum of elements, printing all elements. So consider this application of printing all the elements using traversal. So let's suppose we are visiting each element sequentially, then while visiting we can print the element also. So that's why printing can be considered as the application of traversal. So pseudocode for traversal operation looks like this. For I equals lower bound to upper bound step by 1, means for this array lower bound is this, means the least index, upper bound is this, means the uppermost index, and we are having a loop from lower bound to upper bound and incrementing it by 1. So we would traverse this array from 0 to 3, incrementing by 1 means each element. So what we can do by traversal, already discussed, we can process each element. AI means the ith element of array A. So with ith element of array A we can do any processing which we have discussed earlier. We can print the elements, we can calculate the sum of the elements, or we can do anything else which can be application of traversal. So this is the pseudocode of traversal. So the time complexity of this traversal algorithm is theta of n. So if you don't have basic idea of asymptotic time and space complexity, I would like to tell you that if some algorithm is processing for exactly n times, so this can be represented in the asymptotic notations by theta of n. So this is the asymptotic notation when a program or algorithm is running for exactly n times. Okay, so this is the time complexity of traversal. So this is all about traversal. So now we would discuss about another algorithm or another operation on array. So another operation on array is insertion. So here also we would see how this is performed, and the analysis means the time complexity of this operation. So let's say we are having some function for insertion. So the prototype means the function prototype means how the function, what are the parameters it takes and names are included in the function prototype. So the function prototype would look like this. So this is the function name, and the prototype the parameters which is take are array name, item which is the element that is to be inserted, and another index, and the another parameter which is I, which is the index at which the element is to be inserted. So any insertion function which you would implement would have similar function prototype. So let's suppose we have some array. So the insertion can be done at two places. It can be done at the last index, means for this array this index is free. The first index which is free. So if this is called the insertion, this case is called the insertion at the end, and the second case is in when the insertion is done in between. Means, for example, these are the stored elements in the array. We can insert any element in between also. So we would consider both the cases. So let's say the insertion is done at the end, means this is the initial array in which 5 elements have been stored starting from index 0 to index 4. The first space that is free in the array is 5th index. So let's suppose we call the same function which we talked about with these values. Means this is the array name, this should be the array name which we discussed. So the array name, let's suppose, is AR. This is the item we discussed, this should be the item to be inserted. So F is the item to be inserted, and this is the index at which the insertion to be performed. So here, which is the 5th index, we are trying to perform the insertion. So this is the initial array, this is the final array. Means after performing this particular function call, means performing the insertion at the end, this should be the final array. Means the initial array and the element that has been inserted. So I'm not talking about the implementation of the insertion here, but because I have to talk about the time complexity, I'm just explaining the working. So the second case, when insertion is done in between. So let's say this is the initial array, elements are stored from 0 to 5th index, A to F elements are stored in the array AR. So let's say we call the function with the parameters AR, which is the function name, again X, which is the element that is to be inserted, and 3, which is the index at which the X should be inserted. So the third index is this index. Okay, so we have to insert X at this place. So but the problem here is that D is already stored at this particular location. So we should not hamper the array. Means all the elements that are stored in the array should be stored in the array, and this insertion should be taken place. This insertion should take place. So what we can do is, till third index, starting from the end, we would just shift the elements one by one. So for example, this F should be moved here. So I'm writing it here, F is moved here, and this is gone. So, no, this is not gone at the moment. This F is here, and F I just copied here, and now E is moved here. So now F is gone and E is stored here. And I told you, starting from the end, we go till the index to which we need to insert. So we go till 3 because we have to vacate this place. So we just move D also. Now this E is gone and D is stored here. So D is here, but D is redundant because D has already been stored here. So D, E, F are shifted one place. So now we can store X at this location. So we would store X at this location. So this can be implemented easily in any language, C, C++, or Python, any language. But I'm only discussing the working here. So the initial array was what I told you, and this would be the final array. So A, B, C, then X, D, E, F. All the elements D to F would be shifted one place. So A, B, C, X, D, E, F. This is the final array. So when we are talking about the time complexity, this is the operations which are performed in for performing a particular algorithm. So let's suppose we have to analyze this insertion algorithm. The operation which we have performed is this shifting operation. So minimum shifting for this insertion operation is 0 when the element has been inserted at the end. We see if we have to insert element here, we don't need to shift anything. So we just go and place F over here. But if we have to insert any element in between, we need to shift the elements. So what can be the maximum shifting? The maximum shifting can be N when the element has to be inserted at 0th index. So when insertion at index 0. So if we have to insert over here, so then we need to move all the elements, all the n elements one by to the next index. So n shifting would be done. So when we are talking about the maximum number of operations that are needed to be performed, it's n. So time complexity equals order of n. If we again, I told you that you need to have some basic understanding of asymptotic time complexity, because this is derived from the that understanding only. So if you don't know, then just remember this. If we have something to be the maximum number of operations, we talk about the complexity in the terms of order. So previously we talked about the traversal algorithm. Then there the program executed exactly once, so it was theta. But here we are talking about the maximum number of operations. So the time complexity, it is not exactly once, it is maximum number of operations. So the time complexity is order of n. So this is all about the insertion operation, the prototype, the cases, and the analysis. Next we would talk about the deletion operation. In similar way, we would talk about the prototype first. So the prototype would look like this. This is the function name, let's say delete. This is the array name in which we have to we just want to perform deletion. Let's say it is AR, and this I denotes the index of the element which is to be deleted. So again here we have two cases. The case one is when the deletion of when we are deleting the last element. So let's suppose this is the initial array. We have given some array in which elements are stored from A to E, and we want to delete the fourth element. Fourth element is the last element. So we would just go and delete that. So there would be no shifting. but when we want to delete any element which is present in the between, so we would have to perform shifting. So we would analyze that also. So let's suppose this is the initial array, elements stored from A to E, and we just call the function delete AR2, sorry. So we want to delete the second, the element which is stored at the second index, so which is C. So what we have to do, if I delete C, there would be a vacant space over here, so we need to fill that with the elements which are next to it. So we need to shift D here, so D would be here, and again E to here, so E would be here. So the final array would look like this, A B D E. So it is A B D E. So here also, if we analyze the code, the algorithm, it would be like the minimum shifting which is needed is 0, as in this case if we delete the last element, and if we delete the first element, so in that case we would be having the maximum number of shifting. So the maximum number of shifting would be n-1. So why n-1? Because this one element, let's say we delete it, so remaining n-1 element should be shifted one by one. So this should be shifted, this should be shifted, this should be shifted, all n-1 elements should be shifted one by one. So that's why the maximum shifting is n-1. But again the time complexity is order of n. We are not considering this one in this time complexity thing, which we have declared as time complexity, because if you study the asymptotic analysis, then we ignore the coefficient and the constant. So here we have ignored the constant 1. So that's why I have written time complexity equals order of n. So that's all for the array and the basic operations. Thank you.